All right, Owls, this is Mr. O with the final set of flip notes for the wave unit. This one's going to talk about visible light. The EM spectrum is actually found in the back of these notes, and we will do that in class. And then we're also going to talk about wave behaviors. This is 6.P.1.2, the final of the wave sections. We're going to start with talking about wave behaviors. Now, instead of just jumping into that, wave behavior, you have to understand what the word behavior means. Remember, as we go with this, follow along with your note sheet. Write down any questions if you have them. I'd be happy to answer them in class. Remember, you have to be able to read your notes to be able to use them effectively. A behavior is how a wave acts or behaves. And when we talk about this, we're mainly connecting it when it comes in contact with a medium or matter. So it's what will a wave do when it hits a various pieces or states of matter, and they react in various ways. And that's what we're going to focus on this front of the notes. The first of the behaviors is reflection, a word you should probably have heard in your life sometime. There's a picture of a couple of different reflections that are pretty common. By definition, it's the bouncing back of a wave after it strikes a barrier or a medium. You can tell examples of this would be an echo, which is the picture on the left. We're looking into a mirror. That's a sound wave using reflection, and then the mirror would be a light wave using reflection. The next is refraction. Okay, you see a prism down there, and also a stick in water. It could be a pencil in water. We'll talk more about that in a second. Refraction is the bending of a wave as it enters a new medium. The key here is it needs two different mediums. So if you don't have two different mediums, refraction is not possible. Refraction is what causes a rainbow in the sky. It's light reflecting off the water droplets in the sun when you see it. Examples of this is a prism, as seen on the left, and then looking at your foot in a pool. So if you put your foot in a pool, it looks like your foot is disconnected from your leg or bent oddly from your leg because refraction's bending the wave. All right, moving on. And diffraction is the spreading out of a wave through an opening or around an obstacle. Two examples from this would be, one example would be a light from a room into a dark hallway. What I mean by that is, say our classroom was lit and the hallway was dark. If you went into the hallway, the light from our room would spread out through the door opening, as seen in the picture below. Sound does the same effect, meaning if you stood outside my classroom around the corner, you'd still hear my voice around the corner because my sound would spread through the door and around into the hallway in all directions, which is an example of diffraction. The next three are mainly light wave behaviors. First one is called transmission, and that is the passage of an EM wave through a medium. And it's basically unobstructed. If you can see from the picture, and the example I have is light through a window, you can see where it says transmitted. It means that light wave went right through without being affected too much, whereas the other two pictures show it being absorbed into the medium or reflected off the medium. Transmitted means it went right through, which what passage means. The next word is absorption. This is the disappearance of a wave into a medium. An example of that would be your shadow being created. If you stand in front of the sun, you absorb all the sunlight and you cause a shadow behind you because you absorb the light, creating no light behind you. Or a solar panel absorbs all the sunlight in order to take in the energy to be used. The picture I have on the slide, the middle one is showing absorption. The left one is showing reflection, and the right one is showing transmission. And the last of the behaviors we're going to talk about is called scattering. And the scattering is the spreading out of light in all directions because the particles reflect and absorb. Clouds appear white because they scatter the white light from the sun. And examples of this would be a stained glass window or light hitting the surface of the ocean. If you look at a side cut from the ocean, if you're able to, and when the sun rays hit it, it spreads out in all directions, scattering the light. If you understand the word scattering means, in essence, you'd be using the word spreading out to define it. Onto the back of your notes, we're going to start talking about light and color. Light is one of the 7 types of waves on the EM spectrum, which we'll get into in class on Monday or Tuesday. And it's the only part of the EM spectrum we can see. That's why it's called visible light. Each color of light has a different wavelength. And if you haven't remembered since like kindergarten, the old homage of Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. These are all the colors of the rainbow. And when they're together, they appear white. but separated. The reason why they are separated is because they all have different wavelengths. Next thing is a tool we use to separate white light, which is prism. This tool uses refraction, the behavior we just talked about, to spread out the wavelengths of white light. Because all colors bend at different angles, if you use a triangular prism that's clear, as white light enters through it, it will diffract or refract the light and spread it out, allowing you to see the rainbow. This is what happens when sunlight hits rain droplets or water in the sky. This is why you see rainbows after a storm passes in the sky, because you are seeing refraction of white light as it spreads out. And the reason why a rainbow looks bent is because they all bend at different angles. Reflection and absorption. We talked about both of these, but the reason why we're addressing this here is pretty big. The color of an object is determined by the wavelengths it absorbs and the wavelengths it reflects. So you have to understand reflection and absorption to understand how color works. And the color of an object is based on the wavelength that it's reflecting. So if your notebook's pink, it's reflecting pink. If a table is green, that means it's reflecting green. If a red apple is there, it means it's reflecting red. There's some exceptions or some special cases. White's one of them. White objects reflect all colors and they absorb no colors. So when you see something that's white, when it comes to color, and this is not based on ink, white light is the presence of all color. Black, on the other hand, is the exact opposite. Black absorbs all colors and reflects none. So black light is actually the absence of color because it's absorbing everything and reflecting none. This is why you see something that's black. And then any color in particular, you can include this as blue, red, green, yellow, doesn't matter. An object's color is the color it reflects, and the other colors are all absorbed. My next slide will show some examples of that. See the apple? White light, which is the rainbow. You have to understand that white light is all colors of the rainbow. Goes into the apple and it reflects red, so you see red. All the different cubes are reflecting the color that you see them as, and every other color is being absorbed. And the prisms show you just a generalization of white light, all colors reflected. White light, no color reflected for black. White light, red is reflected for the red triangle, and green for the green pyramid. So these things, it's just one of those things you have to understand that these behaviors are making this happen. And the last thing we're going to talk about are different materials and how light is affected by them, or how light interacts with them or behaves with them, hence wave behaviors. First thing is called transparent. This is when materials that allow most of the light that strikes them to pass through it. This is caused by the wave behavior transmission. An example of this is clear glass. This could be like a window, a snow globe, your glasses, a glass you're drinking out of. Anything that's clear glass is easily showing transparency. The next is translucent. These are materials that transmit some light but also cause it to spread out in all directions. This is caused by the wave behavior of scattering. You can start to see how these wave behaviors build on each other. Examples of this would be a stained glass window, which is shown to your left, or like tinted windows, like in your car or sunglasses. And these colored glass waters with green and red and blue also show something that's transparent, because some light's getting through, but it's getting scattered so you can't clearly see through it. And the last of the materials we're going to talk about are opaque materials, which means materials that do not allow any light to pass through them. Now this can be caused by one or two or three things. It can either be caused by something completely reflecting, which I spelled wrong there. It can be something that's completely absorbing, or it can be caused by both. Examples of this would be like a brick wall or a wood floor. I also have that dice there. If you put light on that, nothing's going to go through that because it's going to absorb all that. And then the apple is not letting any light pass through it, so it's opaque. Those are your notes. I know it was a lot. If you have any questions, please write them down, and we'll discuss them when you get back to class.